Okay guys, so we just had our first Onshape review, or should I say class here. So, and a lot of you were a bit confused about how we were actually making these parts, about the linear patterns and the hole patterns and such like that. So I'm making this video to give you guys a bit of a more in-depth guide. Just gonna make sure I'm still recording. Okay. A more of an in-depth guide into how we're gonna make. I'm gonna go from start to finish. I'm gonna explain each step, and we will go from there. First, we're gonna go into my document, labeled as such, and you guys can see today's work we did today. You see the tubing here and the assembly as well. If it will load for me, thank you. So we're gonna go step by step from the beginning. I'm going to make sure I go through each step very thoroughly. Okay. So first thing, you're going to go in your part studio. I'm going to make a new one, but you don't have to. I'm going to make a new part studio. And a few of you were a little confused. I'm going to go ahead and make the sketch right now because I think all of you got into the sketch. But once we select our rectangle tool, remember in Onshape it is click and let go. Just one click will give you the enough to just, so I'm just going to click once, and now you see those two numbers pop up, and I can just drag without even holding down the mouse button to make my rectangle. And when I want my rectangle to end, I click once again. Now I have a rectangle, but none of the dimensions are actually defined. So this is a random number, this is a random number. I want these to be very exact. So to do so, I can either click D on my keyboard, or I can click this dimension tool that's right below here. And it looks like it's a little two lines with an arrow in between them. I'm gonna click that tool, and we are working with 2x1 tubing. Now I'll show you on McMaster Car. Now the reason we're doing 2x1, I'll show you real quick. I believe it is in their stock metal. Well, I believed so, but I may have been let's see right here, got some raw metal. Let's do tubing. Let's see what they got for tubing. Got a few things here. So 2x1 metal tubing, most likely. Yeah. So these is actually a readily available stock that we can actually buy, and is in our workshop. And that's why we're using this dimension. So we go back to our Onshape. Didn't have to do the step I just did. That was just for reference. And we actually, I'm going to do this one more time. We're going to click the dimension tool up here. Going to click once on the edge that you want to define. In this case, it is this one right here. Click one time and move your mouse up. Do not click and drag, just move it up. And then click once more to bring up your dimension. And your dimension for this is going to be 1. And then hit enter. And now this length from this point to this point is 1 inch. It's an imperial measurement, so this is going to be 1 inch. Now, if you want to, if you made a mistake, you want to change this. To change this measurement, you're going to double click to change the measurement. That's only after you have defined it the first time. So, if you want to, we'll do the same here. So I'm going to click once on the edge I want to define, drag out without clicking on my mouse, click once, and enter in my number. But let's say 2 is not the number I wanted. I can double click and I can change the number again, but in this case 2 is the number that I wanted. Okay, now that we have our rectangle, this is the 2x1 that we want, that's what we have in the machine shop, we're going to go to the offset tool. You can use this by clicking the O button on your keyboard, or you can actually just click this B looking shape at the top here, and now you have your offset tool. And you're going to select each side because you want to offset the entire rectangle. So select each side just once, and yours may look like this if yours does look like this right here, you're going to click the arrow, the white arrow, to reverse the direction to the inside. Now once you have this, you can go into empty space and hit click once, and it will bring up your dimension. And for this, we're going to be using 0.125, and that's going to be an eighth, and this is 1/8 inch wall thick tubing. Think of this as hollow inside of here, and this is the wall of your tube. So this is all hollow right here. Think of this as the hollow part of your tube, and this is the rest of it right here. Now once you actually have this right here, we're going to go over to this over here. This is the extrude. You can access this by doing Shift E, or you can access the extrude by just clicking this button right here. And it should automatically select this face to extrude 1 inch. Now we want this tube to be a bit longer than 1 inch. So here at the depth area, you're going to input 2/8 inches. And that's going to give you a 28-inch long piece of square tubing. And that's exactly what you want. Now let's say, for instance, let's go back to 1 here. Let's say, for instance, that this is not working. It's just this page, and you're confused. If there's nothing selected, which there should be, if there's nothing selected here, you're going to select this face right here. You're going to click in between these two lines, and then it'll give you the same result. That's only if this field is empty. Now I'll go back here. If you actually are in Sketch 1, if you're inside of it, you'll see this. If you're inside of it right here, you'll be in Sketch 1. Now if you're in Sketch 1, you can go ahead and use that to extrude, and it should select that face for you, but that was an instance where it was not selected for you. Go ahead, select 2/8 for your length. That way you have 28 inches of tubing to work with, which is the measurement you need. Once you're finished with that, go ahead and hit this check mark right here, and you've successfully made your first hollow square tube. Okay, what I was going to tell you was that there is a way to copy and paste this, but I found out that you cannot edit the length of this bar after you cut and paste. So we're just going to go back to what we did before. Make a new sketch, go to the front plane, click this plane, go to your corner rectangle again, click the origin, and come out, not clicking and holding, dragging, and then click just one more time, and that's your rectangle. Define by clicking the define tool up here, click that, and click the edge you want to define one time, and then just move your mouse up, click once again, type in 1 because that is the dimension we want there, and do the same thing on this side. Now we're going to do the offset again, click each side. Oh, that was a bit too early on my part. Oh man, Control Z is the undo button. Ooh. Okay. Click every single side, make you a full rectangle. Make sure that this is pointing inward by clicking it. All you have to do is click it once to change the position there. Click an empty space to bring up your dimension and do 0.125. That's 125 for 1/8 of an inch. Perfect. Now, once we have our second one ready to go, go ahead and do the extrude again. And we're going to do, instead of 28, we're going to do 24. And this is going to be a new part. See how it's already highlighted as new, and you can see part 2 is bolded, which means we're working on it right now. And we're going to hit the check mark, and there we go. That is our 24-inch piece of aluminum tubing. And we're going to rename this one to 24. Alrighty. Once you have that in place, what you're going to do next is the hole patterns on these bars. So each bar needs its own particular hole pattern, although we do use a pretty standard hole pattern. So I will go ahead and show you. Go to your right bar right here, the right side, click that, and go to sketch, and instead of hitting one of these, you're going to hit on top of the bar. So you're going to click right on here. And that's going to make this extrusion the new face of your sketch. You see all your tools are right here. Go ahead, zoom in on the end of that bar right there, and click the circle tool, center point circle, or you can hit C on your keyboard. Click that once, come over to around the corner of your bar right here, and click once, drag, 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 no clicking, and then click one more time. Now we have a circle. Now this is going to be the beginning of our hole pattern. We're going to define this circle, and to define the circle, dimension tool to the ring around the circle. Click that once, drag it out without clicking, and click one more time, and type in the number 0.201. That is our standard hole pattern size for our holes on the square tubing. Now to define a hole to the edge, we usually go from the center. In rare cases, you will go from the edge, but for this demonstration, we will be going from the center only. Click the center of the circle and the top of your bar. Define that as 0.25, 1/4 of an inch. And do the same thing for your y-axis. Click the center of the circle, then this edge, drag your dimension out, and then do 0.5, 1/2 of an inch. Now you have the beginnings of your hole pattern. Make sure you memorize these numbers because you will need to use them on the next stage over there. Make sure this is 0.5, 0.25, and 0.201 for the hole size. Now we're going to be using something called linear pattern. This basically copies our dimensions here in a direction either forward or down or up in Z or Y dimensions. So go ahead, if these four patterns aren't here, they may be hidden under a menu like this. Click the drop down arrow and select linear pattern. Click on the circle you want to make a linear pattern. In this case, it's this one right here. And you'll get this funky little menu here, but this should look a bit familiar from our offset. Now this arrow right here is actually in the wrong direction. It's going to make a column over here over nothing. We don't really want that. So go ahead and click this arrow right here. And there's a little number attached to it that says 1x. That means it's only going to make one row right here. We don't want that, so we're going to actually make this number a 2. That way we have 2 rows of parallel lines of circles. We're going to make the distance in between each of these, and it's already here for you, so don't hit the define tool. It's already here for you. Just double click on the dimension to change it, and change this to 0.5. 0.5 in between each center of our holes there. And this number is actually the amount of holes. We're going to do this last in our in this part of the sequence. Once you have that, change this number. So we want this hole to be 0.25 from the edge of this edge right here. If we already have 0.25 here and then 0.25 here, which means there is a 1/2 inch total of clearance from 2 inches wide. So 2 inches minus 0.5 is going to be 1.5. And now you have a linear pattern, but you don't have a lot of holes. Now for this demonstration, usually you will have to guess and check the amount of holes that you'll need. For example, what if I did 60? If I wanted 60 holes all along down the side, and the way I did this to make them all black like this and to find them, I just clicked an empty space after I typed in the 60. To make all of those, see, do have some holes that are on the edge here and are off to the side. We found out the number we needed was 55 holes total down the length of this, and that fits just nicely here. Your last hole should be a good amount away from the edge, but not on the edge. Now, once we have all of our holes like this blacked out, go ahead up to this extrude key, and instead of adding, you're going to actually click this remove right here. So click the remove, and you're going to have to go to this menu right here where the little arrow is and go through all. That's going to make the holes extrude through every single piece of metal in the way. And once you confirm, you can see holes on this side. You see right here. Click that check mark, and now you have holes through the center of the your hole pattern is made on both sides. Now this is where it's going to get a bit easier in kind of pasting. We're actually going to right click this sketch, when you're outside of the sketch like this, right click this sketch and do copy sketch. And you're going to make a new one right here, and you're going to put it on this bar, this grayer bar right here. Once you have that, go ahead out in free space, right click and say paste sketch entities. It's going to copy your hole pattern over to this one. Now this is a bit convenient because you don't have to type all those numbers in again. For me, it's a bit more convenient. I'm going to move this over to just about where it was. And you're using these arrows, clicking and dragging these arrows. No, okay. I'm just going to place it right here so it doesn't over-define itself. And I'm going to go to this top hole here and type in 2 dimensions. From the center to this edge right here is going to be 0.25. And from this center to here is going to be 0.5. And that will fully define this one. And one number you will have to change is this number. For the 24-inch model of the square tubing, it will be 47 holes total. And that way, now you have 2 hole patterns. Now all I have to do is extrude this one, hit the remove button, go through all, and the check mark. And the check mark. And now you have a hole pattern through both. Now there's one more hole pattern we have to do on top of each one. This is a bit less of a complex linear pattern, but is still nonetheless important. Click the top of your first bar, select your center point circle, and come down to about the end of it. Make a nice circle there and define that circle as the 0.201. Once you have that defined as 0.201, select the center of the circle, and select the outer edge and do 0.5. And since it is an inch everywhere, we're going to be doing 0.5 everywhere. So 0.5 there too. So now it is defined here to here, from here to here, and from here to here as 0.5. Those are your numbers. Just take a look at those, make sure you have them all right. Okay, let's make another linear pattern here. Select your circle. Now what we're going to do here is we're actually going to increase this one to 55. That will give you 55 circles down that way, and change this number to 0.5. And that is how many circles are, that's the distance between each circle, and that's the distance, and that's how many of them. And you may notice there's a bunch over here. And this number right here defines how many rows there are. So if it's only one row, there's no circles here. And so it remains just on the bar. We're going to click this and confirm we're not over the edge on our, on our end. We're not, so we can go ahead and extrude this, remove it, and go through all. Click the OK, and look at that, a fully defined bar. We're going to do the same thing here. We're going to go to copy sketch for sketch number 5. And then go over here, create a new sketch on top of the other bar now. And we're going to actually paste sketch entities once again to save us a little bit of time here. Move it over, nice, decently close. Don't, make sure that you don't, one thing to note is that make sure you don't snap to a definition point. Now that basically means don't have one of those horizontal. Oh man, I think I just did it. Oh no. It's just giving me suggestions, that's all. So once you have that, you're going to go up to here, select the center of this circle, go from here to here, This is actually going to be, sorry, that was the wrong dimension. So from here to here, since this is on the outside, go ahead, type in negative 0.5, and that will move it to the inside. And then from here to here is obviously 0.5. And you do negative 0.5 there to move it on the inside of that plane. Think of this as your y-axis on a graph. If I have a circle out here, and I want to define it as 0.5 away from this edge to here, 0.5 from here to here, and I want this circle to be on here, if I type in 0.5 here, it's just going to go to 0.5 from here to here. But if I type in negative 0.5, it reverses and goes on the other side. And that is why we put a negative 0.5 right there. But anyway, change your amount to 47 to give yourself the proper amount of holes. Let's just double check here. Double check that's a nice amount of holes. It is. Hit the extrude key and hit remove through all and extrude. Perfect. Now you have a hole pattern on both of yours, and we can move on to your assembly. So to make it, you should already have your assembly one already made for you, but if not, you can click this plus icon and create an assembly. But you should have one already made for you by default. Go ahead to the top view. That's where I like to start mine. We're going to insert from Part Studio 2, which is the, or 3, excuse me, this is the one we just made. We're going to make two 24s and two 28s. And this will actually make us a complete square. And the way this will work is that there's 4 inches of clearance on each one of these to make it a nice and rectangular chassis. Now, to mate all of these together, we're going to be using something called a planar mate. The planar mate button can be found up here and be compressed by the letter M. Oh, excuse me. I guess they're all M. What if I just do multiple? Nope. So it's just the planar mate button at the top with a square and 4 arrows. Click that for me. And the first thing we're going to do is we want this outside corner to be flush with this corner. So what we're going to do is we are going to select the outside corner of this facing out. So you should see green and red but not blue. And then you're going to come to this one, and on the side of it you're going to select that point right there. Now it's going to be a bit wonky to begin with, but if you rotate it around a little bit, it's going to fit just fine. Right like that. Perfect, 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 perfect. Now, once you have that complete, and I believe this might be a bit different in the other assembly. I'm going to just check really fast. No, it's actually the same. Wow, look at that. We got lucky on that one. It's the same right there. Now, you might think it's done already, but it's most definitely not. When I move around the assembly, it is still wonky, and it still moves very, very erratically. So we have to planar mate 3 times at minimum to really cement these two together. Select the top, select on top of your bar, one corner, and then select the corresponding corner on this bar on the top, and that is going to mate them on the Z axis. So now this one will go high and this one will go high with it. But now we're going to be doing the Y axis. Select this corner right here on the inside facing your bar, and then select the corresponding corner on this bar facing the other one, and they will mash together and it will create a nice seamless bond between the two. And now what I did earlier was that I realized that once you make one of these, you can just copy this and then rotate it so you don't have to make a billion different planar mates by hand. So go ahead and highlight these 2 bars or click on both of these bars, hit your backspace key to get rid of them, And what you're going to do is you're going to highlight this whole section, do copy, Control C and Control V to make an exact replica of what you just did. Go to your top view and we'll get this situated. Right now, this is actually the wrong direction. To make these together, this end needs to come over here. So the first thing is we're going to go to our right plane. We're going to highlight the section we want to rotate and bring this node. Once you highlight any collection of parts, you'll be given a transformation node. Select the center point of the node right here and bring it to the approximate center of your bar. Now what we want to do, we want to rotate 180 degrees this way to line it up with what we know. This needs to come here, but this end needs to come over here. So we've lined up this end facing the right way, but this needs to also come the right way. So go to our front end here, at least for me, highlight the part you want to rotate, and that's approximately about center. And we'll rotate 180 degrees that way. And now you have two halves that you can almost see the frame coming together there. And the only thing we have to do now is planar mate this to here, and we'll be finished with the frame mating. Go ahead, go to planar mate. Let's go ahead and start off with the corners again. We want this corner to be on this corner. So let's go ahead and select the front corner like that. And we're going to put that front corner right on this corner right here. Perfect. Now before we go anywhere, we're actually going to mount this flat corner right here, and let's get some separation to this flat corner right there. Now we have our Y, and actually we have our X and our Y, but not our, actually, we need our X, that's right. So we're going to select this side right here to be flush with this side, and now we have a fully defined frame for a robot. Now obviously this needs a lot more, and we'll go over that in more trainings as we go along, but right now this is the base of a robot chassis, and it's actually very similar, and I'll actually pull this up right now for you guys. It's actually very, very, very similar to the FRC 4188 2020 chassis. Now I'll show you the drivetrain for this one. Now the drivetrain is a bit more complex because it is it's full of gearboxes and bumper rails, but you can see it's just a bit more of a complex version of what we just did there. You can see where the planar mates were made, and I don't know why every single mate connector is showing at the moment. It's really bogging down the computer. I don't know if maybe I can hide those. Evidently not, but you can see right here, you can see this bar is planar mated to this one. The only difference being is at an offset of a certain number on the x-axis. You can see it's kind of in a few inches there to give room for the bumper rails and the wheels here, as well as you have different gearboxes and stuff like that. Back to our presentation though, or our project. And next, once you have this completed, you're gonna have to, your project was to create a bracket. And the bracket was supposed to be this thing right here. This was a bracket example. You're gonna create an L bracket, which is the shape of an L, but this was an example of how to create a piece of sheet metal. But we'll go over it one more time just so we make sure the process is correct. For sheet metal, I like to start on top and create a new sketch on the top plane. Next, I create a rectangle again at whatever really shape I would like it to be. So what I do here is I define this as, let's go 0.75 inches. And we can make this 2 inches. Which is perfectly fine because when you're cutting out sheet metal, you can cut basically any shape you want out of the CNC router. So these definitions are not set in stone by any means necessary, but it is nice to have. Next, we're going to make some circles, or actually, yeah, we're going to make some circles as holes for our bracket. Make a circle right there. Define this as 0.201 because that's the same size on our drive rails. The center of the circle to the edge is 0.5, and this one should be half of 0.75, which is 0.375, I believe. Another thing you could do is you can actually do math in these boxes. So you can do 0.75 divided by 2, and you will get, yeah, I was right, 0.375. Now go up to your, your linear pattern, select that, and select the thing you made. Reverse this direction to get onto your bracket. Make sure it's only one row. And make sure there's about 3 holes right here at about 0.5 inches apart from each other. That seems about right. Go ahead and click an open space to define and extrude. Now the thing about sheet metal is we have the shape of the metal is not important, but the actual width of the metal is important. We do not have 1 inch thick aluminum sheet metal for you to make stuff. We usually carry it by quarter or by eighth. So we're going to go with eighth on this one because it's a small example bracket. So 125. And that is our piece of sheet metal. You can see it's got 3 holes in it and it's got an outline of a square box. Perfect. So what we're going to do now is we're actually going to go to our assembly again. Our nicely made chassis frame here. We're going to insert a, I believe it's in Part Studio 4 that we just made. We're going to insert this and we're going to introduce a new mate. That's going to be very, very important for cylindrical designs with bearings and wheels and any other item that may be important along the way. We are going to bring this above our chassis. Nice, nice, nice. And we're going to actually go up to our toolbar here and select cylindrical mate. Select that and select the first hole right here on the front. Now you've selected the hole. Now a cylindrical mate is a mate that deals with circles. Anything circular can be cylindrically mated as long as you select the right face. We're going to mate this circle down to this one. And it's going to slap right on there. It looks great, doesn't it? It's not quite there yet. For every cylindrical mate, you will have to make a planar mate. Excuse me, it's just not cooperating. You will have to make a planar mate to make it stick to it. But to prevent rotation, we're going to do another cylindrical mate to the other side. That way, it cannot rotate off of that axis. Close out of your cylindrical mate and go to your planar mate. Drag your drivetrain away from your bracket. Select one of your holes on your bracket and select the corresponding one on the bottom. And now you have a bracket holding these two together. Now, once you have that, now you know what a cylindrical mate is and how that works. The challenge for you is to make an L bracket with the right dimensions that will cover 1, 2, 3 holes on this side, 1, 2, 3 holes on this side. And you're going to have to put 8 of them on this chassis, 2 per each corner. 1, 2, 3, 4 on this side, 5, 6, 7, and 8 on this side. Now I'll give you a hint. How do you make an L shape and Onshape? That's quite simple. Take your rectangle tool, select the corner, and go in the direction you want the L to go to. Now I'm not going to define this because I want you to find out the dimensions that work for you best. And I want you to make the holes here to make it work. But again, this is all up to you, but this would be how you make an L shape, and you can see it extrudes like that as well. And I'm actually going to get rid of, oh, I have to delete it manually. Whoops. That is up to you. I want, the task for you is to be able to make that bracket using the tools that you've learned in this presentation and put 8 of them on here side by side by side. 8 of them, 1, 2, 3, 4, and then on the back 5, 6, 7, 8 to create a strong base chassis for our robot. If you have any questions, feel free to email me at the address that I emailed you this video at. And if you have any concerns, feel free to reach out as well. If you are having trouble accessing the Onshape team of Columbus Space Program, make sure to send a message to me via email, and make sure you specify you're not in the Columbus Space Program team here, and then send me the email that you signed up for Onshape with, so we can add you into our data banks. Okay.